Okay, so when you get an identity, you first see if you can simplify anything using the identity sheet. And if not, you convert everything to cosine and sine. And also consider factoring if you need to. Okay, when I look at my identity sheet, and I'm going to hone in on the Pythagorean identities because those are the ones I'm not used to looking at. What is this equal to? So this is equal to 1. The rules of the game. You cannot move anything across the equal sign, but you need to make both of these equal to 1, okay? So if I don't know what to do with tan and cotan, I'm going to make tan sine of x over cosine of x, because I'm using the second rule, times cosine of x over sine of x. Now I want everybody to see on your sheet where to find what tan is equal to and what cotan is equal to. It's the second down on the left column, I believe. So you can see those identities. You see where I got it from? I'm not making up stuff. I'm taking stuff off of this sheet. The sheet is your little... So now, this cancels with this cancels with this, and this equals 1. So I am finished. Both sides are equal to each other. So this one, if I look at an identity, secant squared equals tangent squared plus 1, that to me would make it more complicated looking, right? It's already simpler than that. So never go for something more complicated unless you have a plan, okay? So I really can't convert these to anything pretty. So I'm just going to make this equal to cosine squared of theta, because isn't cosine and secant the reciprocal of each other, plus sine squared of theta equals 1. And this is the Mickey Mouse of all identities. He's the most famous of all. I told you to really pay attention when you see him. That equals 1. So we're done on that one too. We cannot use Pythagorean identities for this because there's no tangent squared and cotangent squared, okay? So we can't use it for this. So we've got to go to changing it all from sine to cosine. Now, to sine and cosine. Now the guy on the right is more complicated. We want to make the guy on the right look like the guy on the left. So what I'm going to do, and this is a little harder, is I'm going to take this as 1 over sine over cosine plus cosine over sine. Now this is where kids have trouble because they can't remember what they learned in 5th grade on how to add fractions. So we're just going to look at the bottom section here. Okay? If we need a common denominator, this guy here needs a sine and this guy here needs a cosine. Okay? So whatever you do downstairs, you have to do upstairs. Everybody see what I did to get a common denominator? All right, so now I've got 1 over sine squared of theta plus cosine squared of theta all over a common denominator of cosine theta sine theta. So when I have 1 divided by this fraction, that equals 1 times the reciprocal of that fraction. Okay? So what do we have here? What is the basement equal to according to your identity sheet? What is the basement equal to according to your identity sheet? So this guy's equal to cosine of theta, sine of theta on that side. Well, it still doesn't exactly look like the left side. So let's just do a little bit of looking. If secant is in the basement and I want to bring him up to the upstairs, what does he turn into? Who is secant the reciprocal of? A good guess, isn't it? It's the reciprocal of cosine. So now I have that this side equals that side. So I look at my identity sheet and I don't have any identities that can help me out immediately on the Pythagorean ones, right? Because you don't have anything that says secant squared, sine squared gonked together. So that's not an identity I can look at. So what's my next step? What do I do if I can't find an identity to make it simpler? So I need to convert these to cosine and sine, and I'm going to get 1 plus 1 over cosine squared of theta times sine squared of theta. So that becomes 1 plus sine squared of theta over cosine squared of theta. When you multiply fractions, you multiply the top and the bottom. And what is sine squared over cosine equal to? It equals tan squared of theta. And what is 1 plus tan squared of theta equal to? Now look at your Pythagorean ones. Isn't that a miracle? So we made it look like the top. So this is the common denominator. If I put them downstairs, I have to put them upstairs. Okay? So now I make that one fraction, sine squared of theta minus sine squared of theta cosine squared of theta all over cosine squared of theta. So we have to consider factoring. We're going to factor out the sine to see if we can make this a little simpler. Okay? So factoring doesn't change. It just gets really ugly in pre-cal. Okay? This usually leaves kids in shock, and you guys look like you're in shock right now. All right. So 1 minus cosine squared, what does that equal to? So now we have sine squared of theta and sine squared of theta all over cosine squared of theta. Well, now I'm getting kind of antsy because it still doesn't look like the right side. But can I convert sine over cosine to tangent? So now I have tangent squared of theta, sine squared of theta, and I am done.